Okay guys, so welcome back again to another video. So today we are going to talk about the biosynthesis of ubiquinone. So if you have heard about these type of molecules, I hope you know that these are very important biomolecules which when we're talking about the biosynthesis pathways, metabolized reactions and stuff, ubiquinones take a huge major part. So let's talk about its synthesis pathway. So I'm going to start it with this particular molecule. In first step, I hope you know that we are going to oxidize this particular part into a carboxyl group. So the name is that beta oxidation. I hope you know about it, but if you don't know, in your free time just search for it, you will get the idea. Not a big deal. So it's completely fine if you don't know, if you have no idea about it. It has no effect on this particular reaction, but it's better to have an idea about beta oxidation. So in the first step, you can convert this whole part into a carboxyl group over here. So which we are going to do is beta oxidation, and then here we have another group. So this means N means this is a polymer, right? I mean there are this is a chain molecule. So on this part from here, we can connect it in our next step to this particular place. Here you can see in this reaction happens, this OPP group, this phosphate group, this is going to be released, this is going to be removed. So this carbon over here is this one. If I number it like 1 2 3 4, this is 1 2 3 and 4. This is just a hydrogen, right? This is just a hydrogen. Okay, so now we are on a position like this. Now in our next step, we are going to do two synthesis pathways, which is first what happening is the hydroxylation. Okay, basically we are going to introduce a hydroxyl group into this particular position, and then secondly we are going to introduce alkylation or alkylation, because like you know, when we have introduced the OH group over here, right, OH group onto this position, then we are going to introduce the alkylation, which means we are going to introduce a methyl group to this particular oxygen, right? So we have this particular product here. You can see we have the oxygen. To this particular oxygen we have introduced a methyl group. I hope you know about these alkylations. We have talked lot of things, we have talked lot of examples regarding this alkylation process. We have talked it with SAM. This is very important, right? If you have no idea about this particular SAM reactions, alkylations, I highly recommend you to go back to a particular video and watch it before you before you go in further in this biosynthesis process. These are very important. These are general reaction basically. So now we are in this particular position. I hope you are okay. So in the next step, what we are going to do is we are going to do a decarboxylation. Here, this carboxyl group will be removed as a carbon dioxide. So we are going to do decarboxylation. This is not we are doing, like these are biosynthesis pathways. So you know this all happens in the biological system. So these are not simple reactions. Like you can't use these simple reagents to do particular these reactions. These are enzyme driven reactions, right? You get the idea, right? So now when we have this particular molecule, right, then decarboxylation will be happen to remove this particular carboxylic group. Now it's okay. And then what happens is oxidation, which means we are going to introduce an oxygen group onto this particular carbon atom. Now we have this particular molecule. Oxidation. Yeah, we are going to oxidation, which means we are going to introduce this oxygen, and we are going to convert this hydroxyl group to carbonyl group also, right? Basically oxidation, right? This is oxidation. Here we have the oxidation. So we are going to oxidize both these positions. Now we are in this particular position, and then you can see when it comes to the next step, we have introduced a methyl group to this particular carbon. So you can see the methyl group is being introduced to the carbon, which means it's a carbon methylation. So we can use, like mostly it is using SAM molecule. Again alkylation, this is the alkylation process. you can see that alkylation, if you have watched our previous synthesis videos also, like these alkylations are most, we are going to find it most often in biosynthesis process. So again, that's why I have told you that the alkylation is much more important in these reactions. So here we have the carbon methylation, or we can say carbon alkylation. So we have introduced a methyl group to this particular carbon, and in the next step, okay, in the next step, you can see we have obtained this particular molecule. So we have done several reactions. First one is the hydroxylation onto this particular position. So OH group will be attached to this one, and then secondly we are going to use SAM methylation, okay, SAM oxygen O methylation, because like just like here, right, just like here, we are going to add the methyl group to this particular oxygen. So O methylation. So basically we are SAM. SAM is the molecule which is SAM is the coenzyme which drive this reaction. So yeah, I have done a mistake here. There should be a methyl group. Now we have this particular molecule which is ubiquinone N. We call this N because of this N group, right? So this is our molecule. This is our target molecule. So you can see like it's not that hard. It's not that complicated one, but like there are some general reactions inside our this biosynthesis pathways, like oxidation, decarboxylation, hydroxylation, this alkylation. These are the same reactions, same steps which are occurring often. Like you can take like 100 of biosynthesis pathways, and you can see like this every steps contain these kind of reactions, these kind of simple reactions. So basically, if you want to be expert on this biosynthesis pathways, if you want to like understand this biosynthesis mechanism, first my advice is go to the basics. These are the basics, like oxidation, methylation, alkylation, SAM, DNPP methylations. Likewise, these are the basic reactions. Go to it, understand those general reactions, then you can easily understand the whole biosynthesis pathway. You can see the whole biosynthesis pathway, whole metabolism pathways, these mechanisms are based on these several simple reactions. So I hope you got the idea about the ubiquinone. If you are free, feel free, like go to our Facebook page, Land of Learning. Like we are talking about much more, like the practical usage of this molecule, like how we can use this ubiquinone. Like we have discussed more about it, so you can easily find those articles in our Facebook page also. I will put a link below. So thank you again. We will meet in next video.